Hello, beautiful people, and welcome to Teaching Sylvanas Math. Today we're going to be covering graphing exponential functions. This is kind of like a how-to video. But before we begin, I would like to bring you over to our website. So if you go to teachingsylvanasmath.com, it's going to bring you to this homepage. Now on the homepage, you have some options. You can go ahead and click on YouTube here, and that's going to give you or send you directly to my YouTube channel, which you can identify all or watch all videos there if you want to do that. You also have an option of meeting Sylvanas. So if you click over here at meeting Sylvanas, I highly recommend that you do. You get to meet my beautiful kitty cat, who is the inspiration behind teaching Sylvanas Math. So you can see her here. This is her Instagram page. So if you'd like to follow her on Instagram, go ahead and do so there. And then if you go back to your home screen, you have the option of clicking the class that you'd like to watch videos for. For this school year, I have Math Foundations, Integrated Math 1. This is also Integrated Math Support, and then Integrated Math 3. Now, I do want to mention that some of these videos also work for other classes. So if you have an algebra class, videos will work there. If you have an Algebra 2 class, also Integrated Math 2. Content is very fluid from IM1 to IM2 to IM3. So go ahead and take a look at the website. So if you click on IM3, since this is an IM3 video, it's going to bring you to the screen here where it shows all semester 1 and all semester 2 videos that I have up thus far. You can go ahead and take a look at the names of them. And then again, if you're not in Integrated Math 3, but you are still interested in watching my videos, go ahead and click on the videos that interest you, and then it will directly take you to the YouTube video. All right, let's go ahead and get started with today's video. Now, like I mentioned already today, let me shift over here. Ooh, you can see my sweater here. There it is. Today we're going to be focusing on how to graph exponential functions, okay? So now there are a few things that I would like to mention. The way that we're going to be graphing, let me get rid of this here and move it around. Come on. There it goes. Let me get rid of that. And that won't go away, so I'm just going to shift it off. All right, so the way that we're going to be graphing might be different than the way that you've learned how to graph these. Typically, we want you to identify and then use your transformation, so like your horizontal shift, your vertical shift, your stretches, your compressions. We want you to use that. But I'm actually going to show you a quicker way of doing it. Now, this does require memorization. If you memorize these formulas, you're good to go. Okay, so we're going to start out with graphing exponential functions. And before I actually dive into the math, I just want to let you know that I am human. I don't know if you guys can hear it. There's a plane coming overhead. All right, I am human. That is my disclaimer. So if you notice a mistake in what I'm doing, please let me know so that we both can learn from my errors. Also, we are recording from home due to what's happening in the world right now. So if you hear anything in the background, that is Sylvanas, and she is running around like a very curious kitty cat today. So let's go ahead and get started with the math. Okay, so the first thing you're going to want to know is your general formula. Now, the general formula or the general form looks like this. G of x is equal to a times b to the x minus h power plus k. Now, I am doing a times. You don't have to put this little dot there. For multiplication, you are in IM3. So you should know that if you have a and b together, you would be multiplying, but I'm doing that on purpose so you know exactly what each little chunk, or in my class I call them bubbles, which bubbles they are. Okay, now that you know your general form, we're going to give you reference points. So for your parent function, okay, so parent function, Your parent function for your exponential functions is, we'll call it f of x, is a lot simpler than your general form, obviously. So you just have your b, which is your base, b represents base, and you have your exponent x. So your parent function reference points, I call them our pretty points. So your pretty points are 0, 1, and 1, b. So it doesn't matter what your base is. X is always going to be your variable. So it doesn't matter what your base is. You're always going to have these two pretty points, these two reference points in your sketch when you're graphing. So those two. Now, because we're having some vertical up and down, we're going to have some horizontal left and right, and then we're going to have our vertical stretches, compressions. We might have some reflections. That being said, these will change, okay? Depending on what our values in our general form are, these will change. So how do they change? These are your parent function points. So again, I'm going to rewrite our general form. And again, our general form is g of x is equal to a times b to the x minus h power plus k. So our original parent function points are 0, 1 and 1, b. These here get translated, get reflected. They change. How about that? They change to h, a plus k and 1 plus h, a times b plus k. Now, one thing I did not mention for the parent function is our asymptote. We do have an asymptote located at y equals 0. So our asymptote, so let me write that down. So our asymptote is at y equals 0 for our parent function. So our asymptote for our general form changes to y equals k. If you have these memorized right here, you're going to be good to go. Okay, you're going to be good to go. I wouldn't even, these here you can get by just plugging in numbers in for x for your variable and then solving. You're going to end up with these. But this is what I want you to have memorized. Let me put that in a thinking bubble. Because I'm going to show you, oh, that doesn't work. I'm going to show you how to use this exact setup for your growth and decay functions. So for both. Now, if you look at your textbook, the textbook that we're using, they use a different setup. They use different points, especially for this one. They use a different setup for that point if it's a decay function. But I'm going to show you that you still can use this one here for your decay function. It's going to give you a different formula than what your book is telling you, but I'm going to prove to you that it is exactly the same thing. All right, so let's go ahead and start with example number 1. Let me shift this up a little bit. I'm actually going to switch colors. Let's go to black. Example 1. So I'm going to do one example of, what am I doing an example of? I'm doing graphing exponential functions. Woo! Took me a little bit. Excuse me for that moment of hesitation. We are graphing exponential functions. So example number 1, let's start with f of x is equal to 5 times 2 to the x minus 1 power plus 1. So our objective, our goal for example 1 is to graph the given function. Okay, so the first thing I'm going to do is I'm going to use my formulas for my points. So formula number 1 is to find our first point. Formula number 2 is to find our second point. And I'm over here searching for different colors so I can use them for you. Okay, so let's do h, comma. Let me shift this up since you can't see it. There it is. So h comma a plus k. Secondary is 1 plus h comma ab plus k. Now, how do we know if this is a growth or a decay function? You're looking at your base. If your base is higher than 1 or greater than 1, then you have a growth function. If your b is a fraction between 0 and 1, you have a decay. Okay, so now how to visually see growth is going to think about when you're growing, you're getting taller. So the way I think about it is roller coasters. So a growth function looks like a roller coaster going up. Decay function looks like a roller coaster going down. Okay, so we know it's going to be a growth function. So let's do some identifying. So let's identify our general form, and I'm just going to write my general form right on top. So I have g of x is equal to a times b to the x minus h plus k. Now we have our a value, we have our b value, and this is where sometimes it gets tricky to identify what exactly is h. Now h, whatever you see here, whatever number you see here, so if you see -1, it's going to be the opposite of that. So our h is +1, and then our k you take with the sign. So our k is +1 as well. So using our identified values, we're going to get our 2 points. So first point is h is +1, comma a, which is 5, plus k, which is 1. So our first point is 1, comma 6. Second point is 1 plus h. We identified h as +1. Now we have a, which is 5, times b, which is 2, plus k, which is 1. So I have my second point is 2, comma 5 times 2 is 10, plus 1 is 11. So we have our first point, we have our second point, and now the only last piece of information that I do need in order to be successful in graphing this exponential function is our asymptote. Now asymptote, if you don't know what that is an imaginary line. Like, it does exist, but we can't see it. So I call it an imaginary line that shall not be touched. So you cannot touch that line. So you cannot ever, 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 ever touch that asymptote line. Now you can get infinitely close to it. You can go super, super, super close. And if you use a graphing tool like online, you can use Desmos. It will kind of look like you're actually touching that value. But when you zoom in, you're going to notice that forever and ever, ever, there will be a gap between your asymptote line and your graph that's going to go super close, infinitely close to your asymptote line, but you cannot touch it. So I'm looking at back up here on my cheat sheet in my bubble. So y is equal to k is my asymptote. So then my asymptote is y equals, what's my k value? 1. So I have my first point, my second point, and now I have my asymptote. Okay, now it's time to graph. I'm going to shift my paper over. Ooh. You guys can't see that, but I'm trying to hold down this paper with a book, and it's not really working. It's okay. All right, let's sketch this. Let's sketch this bad boy. Okay, step number 1 is to identify your asymptote. So we need a line at y equals 1. So the easiest way to know if it's going to be a vertical or a horizontal is find this value. Find y equals 1. So here's our y-axis, and here's y equals 1. And I'm going to put a little dot here. I don't want this dot big because it's not one of my points, okay? And then I'm going to create a line. So do you notice that I have two options? So if you're not sure if this is going to be a horizontal or vertical asymptote, you have y equals 1. So we identify where y equals 1. Then we have an option. We can either go vertical or we can go horizontal. If I go vertical, you will notice that I am on the y-axis, and I cannot be on the y-axis. So the only option here is to have a horizontal asymptote, and now we Show that it is an asymptote by a dotted line. Okay, so I have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, barely made it 10. I'm going to shift this down a little bit. I didn't. Oh, I thought I barely made it. Nope. So we're going to extend this. I'm going to erase this. Get a better eraser. We're going to extend this up. There it goes. Okay. So now we're done with our asymptote. We have 2 points to sketch. So I have 1, 6. So here's 1, and let's find 6. 1, 2, 3, 4, 5, 6. 1, 6. The other one is I have 2, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here-ish. Okay, there it is. Now, this is where stuff gets tricky. Now you want to identify where your y-axis is. Just kidding, it's right here. We know where our y-axis is. What I meant to say is our y-intercept, okay, our y-intercept. So, y-intercept. To find your y-intercept, you need to set x equal to 0 and solve. Okay, so let's see. You're going to have a point that's going to be 0, a number, and we want to know where it's going to cross our y-intercept. So let's go ahead and solve this. Let me shift this up again. So I have f of 0, because x is now 0, is equal to 5 times 2 to the 0 minus 1 power plus 1. Okay, so let's do, when we evaluate the function at 0, this is going to be 5 times 2 to the negative 1 power plus 1. So then I have, that's going to equal to, f of 0 is equal to 5 times. When you have a negative exponent, that means your base and the positive version of that exponent belongs in the denominator. So I have 2 to the first power in the denominator. So now I have f of 0 is equal to 5 halves plus 1. How do we add fractions? So I'm going to show you a little trick. So you can just do 1 and 5 halves, but we know 5 halves is more than 1 whole. So I have 1 and 4 halves and 1 half. So then that means I have 1 and plus 2 plus 1 half, which that means I have 3 and 1 half. So at 3 and 1 halves, that's where it's going to cross the y-axis. Now, if you're not sure, you can do this a different way. You can convert your 1, let me put that in a thinking bubble. You can convert your 1 as 2 over 2. Still a 1, it just looks different. So 5, 6, 7, 7 halves. So 2, and we're going to convert this your improper fraction to a mixed fraction. So 2 goes into 7, how many times? 3, that's a 6, and 1 left over. Still works out the same way. Okay, so what is this number? We're going to change that number to 3.5. So here's 1, 2, 3.5 is about here. Shifting my paper up and down, that's okay. So now let's sketch. So we know, we already identified in the beginning that we're going to have a growth function. It's going to go up to infinity and beyond. Now I'm going to just sketch. There we go. It's going to go up, and you want to smooth one line. So I kind of do a little jagged at first to see where I'm at. And then it's going to go infinitely close to your asymptote line, but not touching. So in your sketch, you do want to leave a little bit of space. And then you're going to go in here and kind of clean it up. So I highly recommend using pencil when you're sketching, because you want it to seem like it's a smooth line. Now this little point is kind of bothering me, so I'm going to shift it just a little bit. Again, we're humans, so this is not supposed to be perfection, but just pretty close to it. So then if it doesn't work, just make your dot bigger and you have your sketch. Again, memorize. Memorize. Once you have these memorized, it's super duper easy to sketch it. Now the other way is to apply your transformations to your original points. You can do that. It might just be a little bit more difficult. Okay. Let's do one example of a decay. So this is example number 2. All right, example number 2, let's do a decay. Let's do this one. F of x is equal to -4 times 1/2 to the x plus 2 minus 2. Okay, same thing. Use your 3 points. Now again, I mentioned before, in your book, you're going to have a different reference point for your h plus k. They're going to do, for your 1 plus h. They're going to have a h minus 1. Don't worry about it. Don't memorize that. It ends up being the exact same thing. So don't worry about it, okay? Stick to your original reference point. So I have h comma a plus k, and then I have h plus 1 comma ab plus k. We have our asymptote at y equals k. And we're going to identify all of our goodness up here. So we have a, we have our b, we have our h. Again, it's whatever number you see here, it's the opposite. This one is exact, so k is -2, h is -2, b is 1/2. And A. Now I'm a little bit confused about A because I know there's going to be a reflection here. So I'm going to take A as is. So I'm going to say A is -4. That way we can take care of our reflection already in our points. All right, let's see here. When it's negative, I just want to point out, it's going to be a reflection across the x-axis. Okay, so if we had a decay function going like this, it's going to reflect, oh, you can't see that. Let's make that darker. If you have something like this, it's going to reflect by flipping it over. So you're going to have something that looks like that. That's just an example. I don't exactly know how this is going to look, but we're going to try. We're going to try. Okay, so let's start. H is -2. A is -4 plus K is -2. H is -2 plus 1. A is -4 times B, which is 1/2, plus K, which is -2. Y is equal to K, which is -2. Let's simplify these. So I have my first point as -2 and -6. Here I have -3, just kidding, -1. And what is this? This is -2 minus 2, and that is -4. All right, got your 2 reference points, got your asymptote. You are ready to graph. I'm going to graph over here. Noticing that all my points here are negative, so I'm going to make this sketch a little bit more on the negative side. And I didn't do that, so let me redo that. And I make my sketch a little bit more on the negative side. There you go. Okay, so step number 1 is your asymptote is at -2. Now I'm looking at my y value, so I need to go down to -6. So 1, 2, 3, 4, 5, 6. And I'm going to do 7, 8 just for good measure. So -2 is here, and I'm going to do my asymptote line. There it is. And then I'm going to sketch -2 and -6. So 2, 3, 4, 5, 6. -1 and -4. 1, 2, 3, 4. And again, we need to figure out where it's going to cross on the y-axis. So to find your y-intercept, you're going to set x equal to 0. So you're going to have a point of 0, comma, number. So you're going to rewrite this. F of x is equal to -4 times 1/2 to the x plus 2 minus 2 power. So f of 0 is -4 times 1/2 to the 0 power plus 2 minus 2. So then let's see what we have. We have f of 0 is equal to, we just have 1/2 squared, which is 1/4. So I have -4 times 1/4 minus 2. So I'm going to continue up here. So I have f of 0 is equal to -4 divided by 4 minus 2. So f of 0 is equal to, what is this, -1 minus 2. So f of 0 is equal to -3. So then I'm going to come back up here. My number is now -3. So this is -2, -3. I'm going to connect, try to be as smooth as possible. And there you have it. All right, you guys. If you have any questions, please let me know. I'm also going to show you a worksheet that you can try to do these on your own. So we did example number 1 already. We also did example number 3. I'm going to show you example number 2, so you can try that on your own. Go ahead and try example number 2 on your own. And then example number 4, I'd like for you to try example number 4 on your own as well. All right, beautiful people, thank you so much for watching. If you catch a mistake or anything, let me know. I am human, mistakes happen. I hope you enjoyed this video. Go ahead and subscribe if you like this video, tell your friends about it. And then, as always, have a wonderful day, and thank you for watching.